So we've learnt the technique of differentiating something simple, like if we have y equals x squared, we've looked at dy dx is equal to, you take the power of 2 down, you go to x2, comes at the front x, and then the power is reduced by 1, so it just becomes 2x. That's how we see it. Now as we get into the next thing, we're actually going to be using the same type of rule. We just need to remember a couple of things. 1 on x is equal to x to the negative 1. When we have a reciprocal, it becomes a negative power. 1 on x to the n is equal to x to the negative n. Also remember, now this is way back from term 1, so it's getting to be a while. Also remember that we have square root of x is equal to x to the half. The cube root of x is equal to x to a third. Now, in general, the nth root of x is x to the 1 over n, right? But then if I have a power of m thrown in as well, and it could either be under the x to the m, nth root of x to the m, or x, the nth root of x all to the power of m, it's the same thing. It's x to the power of m over n. It looks a bit like multiplication. It's actually not. It's x to the power of m over n. And for good measure, if I put it in a denominator, 1 over all that, nth root of x to the m, that's of course x to the power of negative m over n. And again, I'll write it maybe a little bit more clearly over here. Well, anyway, you get the idea. So we need to be aware of these rules to be able to then use the rules of differentiation, which is bring the power to the front and then reduce the power by 1. Now, when you reduce a negative number, if I had negative 1, then it would go to not 0, which we sort of instinctively want to do, it would go to negative 2. And if I have a half, I'd bring half down the front and I'd reduce it by 1 and be negative a half. So we need to convert these, always convert them to fractional indices or negative indices, and then we can differentiate. So let's give it a go. Okay, number 1. We have y is equal to root x. Now I'm going to rewrite this. Always the first step is to say it's x equal to a half. Okay, now we can differentiate. Dy dx is equal to, we've got a power of a half here, so that's going to come out front. Half. Now there's no other constant, so we don't need to worry about that. Half x. 1 minus, well, a half minus 1. So that's going to be half times, all right, x to the power of negative a half. Now, usually we don't want to leave it as x to the negative a half. We want to leave it as a third or square root and without a negative power. So, if we're going to have that, this is going to be half times. The negative part of the power makes it 1 over the half part. It's now positive. I'll write another line, x to the positive half, which is equal to half times 1 on root x, and when I multiply top with top, bottom with bottom, 1 over 2 root x. Now you don't need to take so many steps, but I'm just illustrating how we differentiate. So that would be a simple case, but we always change it to a fractional index first. Then let's look at something like this. We've got f of x is equal to 3 over, don't worry about the next one, f of x is equal to 3 over the cube root of x. All right, so now I'm going to rewrite that. It's going to be 3 times 1 over, well, that's x to the third, which is equal to 3x to the negative third. Now we're going to have to be good with our negatives and our fractions. So let's try differentiating. F dash x is equal to, the negative 1/3 comes out the front. Negative 1/3 times, the constant 3 is unchanged. 3x, now we've got to think about the power. It's negative 1/3 minus 1. Now, it just so happens that negative 1/3 times 3 is just negative 1. So it's going to be negative x minus 1/3 minus 1 is minus 4 on 3. All right, so we now in the negative power means it's going to be over x to the 4 on 3. I realize that there's a few negatives going on, so the negative in front is what makes the whole fraction negative, but the negative power is the reciprocating, makes the reciprocal, flips the fraction. And so the last step is to say, how do I write this? This is minus 1 over. Now, we've got a root sign. The denominator of the root is the root. So, denominator of the power, sorry, is the root. So, that's going to be a cube root of x to the power of 4. The numerator is the power. And there we have it. Now, as an exercise, it is quite interesting to put these into graphing calculators or to GeoGebra or something and to see how the function looks and then how the derivative looks to find its gradient, remembering that we are finding the gradient function. All right, here we've got something which is a sum of two different functions. So we're going to write both of these as negative indices. So this is going to be 2 times x to the negative 3, because it's in the denominator, and 2, though, is in the numerator, so it must be 2 times. Whereas the next one is 5 is in the denominator. So this is actually 1/5 times 1 over x to the 4th. So the first term I think is a bit more straightforward, but this one becomes 1/5 x to the negative 4. Okay, now we can differentiate. So we're going to do dy dx is equal to, the first one, we've got negative 3 as a power. The negative 3 is going to come down. It's negative 3 times 2x to the power of, what's negative 3 minus 1, plus, what do we have? We've got negative 4 that comes down times 1/5 x to the power of negative 4 minus 1. Now that's quite a long way to write it all, but that's okay. Let's have a look. So negative 3 times 2 is negative 6 x to the power of minus 4. Now, we've got a plus minus, that's going to become a negative sign. 4 over 5, that's the minus 4 times the positive 1/5 is negative 4/5 x to the power of negative 5. Now, the last step is to write it as a without negative indices. So this becomes negative 6 over x to the power of 4 minus, this is going to be 4/5 times 1 over x to the power of 5. So my final answer is negative 6 over x to the power of 4 minus 4 over 5 x to the power of 5. So seems difficult at first, but it's not really if you just take your time and make sure you're clear about how you break it up, make sure you take the fractions out or take the constants out and you're multiplying correctly. Now we're just going to do one more, which is a slightly more difficult example. So let's just think about this one carefully. We've got f of x is equal to x plus x cubed over the square root of x. Now, in the not so distant future, we'll learn a technique where you can actually just solve this straight up. But in this case, what you can do is when you have a single term in a denominator and you have a sum in the numerator, you can break it up. So this becomes x over root x plus x cubed over root x. Now, we can actually write these as single things. So if we use the index laws, this is x to the power of 1 over x to the power of a half plus x cubed over x to the power of a half. Now, when we divide the same base, x, and the indices, we subtract. So this actually just becomes x to the half plus, what does this second one become? Well, it's x to the power of 3 minus a half, which is 2.5, or x to the power of 5 on 2. Just write a note here. Note, it's x to the power of 3 minus a half equals x to the power of 2.5 equals x to the power of 5 on 2. Just in case we're wondering. So now we have our two parts of the function, and I know this is equal to f of x. Doesn't look like what we started with, but it actually is the same as that. So I'll just underline that. So we want to find f dash x, the derivative, the gradient function that allows us to find the gradient. So we're going to differentiate it. So we take the half out the front, half x to the power of half minus 1. If you're ever wondering, just write it like that. Plus x to the power of 5 on 2. You bring the 5 on 2 down. X to the power on of 5 on 2 minus 1. All right, now what's this? Half times x to the negative a half plus 5 on 2 times x to the power of 3 on 2. That's 5 on 2 minus 1. Let me rewrite that just quickly. 5 on 2 minus 1. Oh. Okay, so if we do that, now remembering that negative a half is 1 on x to the half, which is actually just 1 on x, the square root of x, plus 5 on 2 times, now x to the 3 on 2, the numerator is the power, the denominator is the root, so it's 5 on 2 square root of x cubed. We're almost there. This becomes 1 on 2 root x plus 5 square root x cubed over 2, given that the square root of x cubed would multiply with the numerator 5. Now, if I really wanted to, I could fiddle around with it a bit and multiply it by square root of x and rationalize the denominator, but I'm not going to do that. So we could take the following steps, but I don't think it's necessary in this purpose. But if you're interested, let me just show you. We could make it this one, the second one I'm going to multiply top and bottom by root x. It's 1 on 2 root x plus now 2 root x on the bottom. Well, what happens when I multiply x to the power of 3 on 2 by x to the power of a half, or 3 on 2 plus a half is 4 on 2. So it actually just becomes x squared. So 5x squared. So this is 1 plus 5x squared on 2 root x. Is that helpful? Maybe. I mean, it's sort of much of a muchness, but look, the first result that we had, perfectly okay to stop here. All right, now we've got a couple of exercises to do, 8.4. The goal is to finish this by Friday week 4, right, which is this week. And to basically be working over it so you're up to date through the Canvas page, etc. All right, and then next week we'll get stuck into some other aspects of the module. All right, thanks.